So can I now invite Todd Schuett, Innovation Project Manager at Kongsberg Norcontrol, to tell us on MASS Remote Operation Center. What can MASS Remote Operation Centers learn from ATC remote towers? Please go ahead.
Good morning, good afternoon, and good evening to all the ICMASS MTEC participants around the globe. My name is Todd Schuett, the Innovation Projects Manager at Kongsberg Norcontrol, which is a leading developer of maritime domain awareness solutions.
And my name is Pia Meling. I am the Vice President of Massterly, a joint venture between Kongsberg Maritime and Wilhelmsen, and one of the first companies in the world set up to operate autonomous vessels.
Today we seek to answer the question posed in the title of this presentation: what can maritime autonomous surface ships, remote operation centers, learn from air traffic control remote towers?
And these ATC remote towers are not brand new. They've been in operation in Norway since 2015. And these towers are both a technological and operational success in terms of safety and efficiency.
As the technology provider for these remote towers, Kongsberg has learned valuable lessons that we can bring into the technology and operations of remote operation centers for autonomous surface ships.
So, what we're looking at here is the operating room at the remote tower center at Bodø, which is in the north of Norway. And each operator position controls one tower. So you can see that several airports can be controlled from this single location. If we look at the operator positions purely from a hardware perspective, we can see the air traffic control operator position here, and it looks very similar to the remote operator workstation for autonomous ships, as you can see in this picture.
So at first glance, MASS remote operation centers and ATC remote towers seem to be very similar. But when we look a little bit deeper, several differences emerge, which must be acknowledged. Perhaps the most significant difference is that remote towers control an airport, not an airplane. The air traffic control operator has no opportunity to take control or remote control an airplane. A MASS remote operation center operator, on the other hand, will be in control of a moving ship.
Another difference is that the air traffic control operations are sequential. The operator moves from one airport to another with only two tasks to fulfill at each airport, namely to support a landing and a takeoff. An autonomous ship remote operations center will typically monitor several vessels at any given time, and switching only to one-to-one control when there is a need for high attention, or there are some operations that actually require direct remote control of one single vessel.
Another very significant difference concerns air traffic control procedures, which are highly standardized and universal. Air traffic control procedures do not change regardless of the airport or the country. However, in the maritime world, procedures differ from country to country. VTS area procedures, port entry procedures, reporting requirements can differ greatly from port to port and country to country.
Yeah, so these differences are very significant and we cannot ignore them. But there are also a lot of similarities. First, the drivers for both the remote towers and the remote operation centers are economics of scale and safety. Remote and autonomous operations have a lower cost and improves also the safety for their users in the remote towers. And small towns that have tiny airports also have very limited access to competent personnel to staff these towers. And this is also quite comparable to the crew shortage that we find in the maritime world. In the northern part of Norway, there are several airports that only have a couple of flights per day. And also on board a vessel, there may be a lot of idle waiting time before the crew can actually perform their jobs. So instead of working long shifts where nothing happens, a larger group of remote operators in either an RT or an ROC can work with higher efficiency and also have a more attractive workplace. They can also access better tools for situational awareness, such as augmented reality and integration of a wide variety of information sources. The robustness and the flexibility of the team increases, and it's easier to attract and retain specialist competence.
The technology employed in each center is also very similar. At first glance, the RT and the ROC operator positions appear to be identical. They both have large monitors, a surveillance system, information management, and communication systems. A remote operator workstation for MASS, however, has some more complex requirements, such as the need to identify the origination of VHF communication when multiple autonomous vessels are being monitored. The remote tower technology in operations has also taught us something that is a bit surprising about the cognitive load on human operators. You remember that one of the differences between remote towers and remote operation centers is that remote tower operations are sequential, while remote operation center operations are more simultaneous. Yet at the same time, both require a human operator to rapidly shift from one situation to a completely different situation. As we develop the ROC concept of operations, we have learned that concerning the cognitive load placed on human operators, we've been especially concerned by this, especially when the operators are switching from one area to the next. What Kongsberg has learned from delivering remote tower solutions is that an experienced air traffic control operator requires only seconds to make that cognitive shift from one airport to the next. And this is an encouraging finding for MASS operators.
Indeed. And finally, through the success of remote towers, we can see that technology is a game changer when it's done right. But it, of course, can become a problem when it's done wrong. Airports want their remote operators to handle more than the ATC operations. So if supporting services like snow removal, firefighting, etc., also are to be remote controlled or initiated by an RT ATCO, the system architecture cannot be closed and vendor locked. So a system-wide open software architecture is required so that third-party systems also can be integrated.
And this need for open software architecture is not limited to air traffic control systems. Systems used in the ROC, such as Kongsberg's Seascope system, increasingly employ principles of open software architecture, including the support for internationally recognized standards and the use of APIs. And what we can now assimilate, both the user interface and the logic from third-party applications.
So, Massterly's first remote operations center will be set up in the city of Horten in Norway and located with one of our pilot customers, the grocery distributor ASKO. Certified navigators and chief engineers will have this as their workplace, in addition to other specialists who will control or monitor unmanned port equipment, such as terminal tractors. Efficient, zero-emission and automated port operations are also an important part of enabling this maritime transportation service of the future, of which the MASS is a vital part, but only one part.
Likewise, airports such as those operated by Avinor in Norway are gradually implementing autonomous systems for other things, such as snow removal, grass cutting, and mobile devices to scare off wildlife on the runway. No one wants a moose on the runway, and if people have to rush out and scare it away, valuable time can be lost. The remote monitoring and control of various mobile units is a similar need that both ports and airports share.
Thank you so much for listening to our talk. We hope that it sparked some new thoughts. The potential of remote operations to increase safety and reduce cost is huge. And we both look forward to continuing this journey together with you. Thank you.
Thank you, Todd. Unfortunately, he cannot hear us now because he is not online at the moment, so we cannot ask him any questions. So